Here's another example of a limit, and this limit, or I should say this function, is nonlinear. And how can we use the formal definition of a limit to prove that the limit as x approaches 2 from both sides of the function x cubed is in fact equal to 8? Once again, we start backwards by doing some very important scratch work. Make sure you have the definition of a limit memorized. That way you know what to analyze. You remember that given any epsilon greater than 0, our goal is to find a delta that works. And the way we do this is go ahead and analyze the distance between f of x and L. And we use absolute value to indicate this observation. We'll go ahead and simplify this. Absolute value of x cubed minus 8. That is the difference of two cubes. So we'll go ahead and factor this. And there are the factors of x cubed minus 8. Now, it would be nice to make sure this is relatively small. If this is relatively small, we could see that this number here might actually stay positive. As long as this number is relatively small, we want the absolute value of x minus 2 to be relatively small, and if so, we could keep this number to be some kind of positive number. So we're going to make a very bold assumption here. We're going to suppose the absolute value of x minus 2 is going to be less than 1. If this is the case, then we get this inequality, and we get something like 1 is less than x, and x is less than 3. So what happens to this absolute value? We'll plug in 3 in there and find out. This absolute value is going to be less than something. 3 squared plus 2 times 3 plus 4. I believe that's 19. So that absolute value is less than 19. Now we're ready to write, well, we're not quite ready. We now know that this is less than something. This is going to be less than the number 19. And what do we want the absolute value of x minus 2 to be less than? It'll be nice if we can make this less than epsilon over 19. That way, when you multiply these two numbers, you will indeed get what? You'll get epsilon. So what is our delta? Our delta is going to be the minimum of two numbers. It's going to be the minimum of 1 and epsilon over 19. Now, when you write the formal proof, make sure your sentences are in the right order. You have to start with epsilon being greater than 0. Then go ahead and declare your delta. And then we'll go ahead and write the cases for delta. So case 1, if delta is in fact 1, what we're going to do now is observe the distances, or the distance, between f of x minus L. Or I should say the distance between f of x and L. Now, since the absolute value of x minus 2 is less than 1, we know that this quantity, x squared plus 2x plus 4, will remain positive, and it's going to be less than 19. So I'm going to put a 19 over here. And what do we know about the absolute value of x minus 2? It's less than or equal to epsilon over 19. This one's already strictly less than 19, and so we don't really have to worry about this equal symbol because this one is strictly less than 19 already. We'll go ahead and write absolute value of x minus 2 is less than epsilon over 19, and that will give you the product of epsilon. We'll go ahead and write case 2. If delta is equal to epsilon over 19, then the proof is just a little bit easier to read. We'll go ahead and make the observation of the absolute value of f of x minus L. Notice the algebra is so similar, very similar. This time the first quantity is epsilon over 19. And just like last time, because the absolute value of x minus 2 is less than or equal to 1, that means this right here is at most equal to 19. We already have this to be strictly less than, so you don't have to worry about the equals 19 part. We'll go ahead and just write the quantity 19 here on the next line. Multiply those two together, and you will indeed get epsilon. So in either case, the distance between f of x and L is less than epsilon. We're now ready to conclude we're ready to conclude the fact that this limit does exist. And not only does it exist, it will exist as the number 8. And that concludes the proof. Now just remember, your side work here, or your scratch work, or your think work is extremely important. And also remember that all the sentences over here is your final answer. And I mean all your sentences over here with capital letters and periods. Make sure you have the sentences in order, and this becomes your entire, or I should say your final answer, okay? But keep in mind that your scratch work is necessary, and you need it in order to write this formal proof over here on the left.